let's move on and talk about the first law. Okay. So there are many, many different versions of the first law. And the one I'm giving here is the one that David gives. And the first law is this, is that the amount of work done on an isolated is to be very important here, on an isolated system to change its state from, say, state 1 to state 2 is independent of how that work is done. Okay? So what do you think this is implying? We were discussing about state functions and how state functions only depend on the endpoints on the state space and doesn't depend on how we reach that between those 2 points. What do you think is happening here? Is this telling us something about the existence of another quantity, a state function?
Yes.
Okay. What should we call that function?
I'm not sure about that.
Well, there's a
Energy.
hint, energy, because there's work, because it's going to change when you do work, right? Because work, whenever you do work, you change energy. That's what we know from from mechanics. So what this first law is telling us, like the zeroth law, is that there exists a state function called energy, which is a function of P and V. Right? And this is called energy or internal energy. Some people use U for it, some people use E. I'm using E now. I might like flip to U at some point, but physicists are not very good with keeping to the same notation all the time. And anyway, so for an isolated system, what the first law is telling us is that if there is a change in E, it's given by W, right? Now we can do this work in many, many different ways. We can squeeze the system, we can stir it, we can do all kinds of stuff, right? And first law is telling us that it doesn't matter, how that work is done. Now, suppose that we take a gas and put it in thermal contact with another gas or another system, which is not in thermal equilibrium. So then what's going to happen? It's going to change its state, right? Because it's not in thermal equilibrium. It's going to change its state and eventually it'll come to an equilibrium. So that means that just by putting in thermal equilibrium with another system, we can change the energy of the system. Of course, this is not isolated anymore because now it is in thermal contact with another system. So the idea is that the way that you can change the energy of a system, you can change it by doing work or by applying or by putting it in thermal contact with some other system where which it is not in thermal contact with. And the change in energy that happens due to that process is called heat. So heat is actually not energy. Heat is a way of changing energy, right? It is a way of transferring energy. Okay.
So,
now, yeah.
Can work and energy, excuse me, can work and energy be like interchangeable as physical concepts, or because they seem?
No, that's the whole point here. They're not, right? Work is not energy. Work is a way of changing energy. Okay, work always involves doing some movement, right? Energy is, energy is not, does not mean, if a system can have energy without having any movement, right? Just like heat, work is a way of transferring energy from one source to another. Okay, so let me just like write down a few words. Okay, Q is the change in energy. The change in energy, like due to thermal contact with another system. Which the first system is not in thermal equilibrium. Okay.
Sir,
yeah.
so does it not make sense to talk about heat when we are dealing with a single isolated system?
If it's in equilibrium, no, it doesn't.
I see. Okay.
Yeah. It's like, intuitively, so suppose that you have a hot, a cup of coffee, and you put your hand on it and you say, oh, I feel heat. So what is happening is that you are absorbing energy from that cup of coffee. So it's a transfer of that energy that is felt as heat, right? So you can't say that, oh, the coffee has this amount of heat. Like you can say, oh, the cup of coffee has this amount of energy stored in it. And you can, depending on what the surrounding conditions are, you can extract a certain amount of heat from it and therefore energy. But heat is the process through which energy is transferred. Okay.
Okay, sir.
All right. So right. So before we kind of move on, let's talk about like reversible systems. Actually, I think let's just stop here. We have 5 minutes, so I just don't want to rush it. Any questions so far?
I have a question.
Yes.
Is there any sense in saying that heat is a passive transfer of energy and work is an active transfer of energy?
Sorry, what was the first part?
Heat is a passive transfer of energy and work is a active transfer of energy. Does that make any sense?
I think you can say that, but I'm not sure how useful that is. It may be useful, yeah. Because I would be more specific, saying that heat is a transfer of energy which happens due to the change in temperature.
I see. Okay.
Due to a difference in temperature, and work is a way of transferring energy due to mechanical, some sort of movement, like a macroscopic mechanical movement, right? So, I mean, we know that microscopically, the transfer of energy due to heat has also to do with kinetic energy, so it has to do with movement, right? Because we know that the microscopic view of temperature is that it measures the average kinetic energy of the gas molecules, right?
So, sir, so is heat like a relative idea? Is there's no like an absolute idea of heat? It's like just a relation in relation of two things.
It's a process. I mean, I don't know what you mean. Yeah, exactly.
So,
Yeah,
like, like if let's say there's a cup of coffee at room temperature and my finger is also at room temperature and I dip my finger in the coffee and I don't really feel anything. So can I say there is no such thing as heat in that context?
Yeah, exactly.
Oh, okay.
Yeah.
So
Is it
just
that?
a question, that chapter 4 of Tong's note, is it self-contained or does it require some previous understanding of thermophysics?
It is. It's self-contained. Yeah.
Oh, okay.
Yeah.
Good. Yes, for me.
I mean, yeah. Tong is a very good writer, but sometimes you have to decode stuff because he packs in so much information
Yeah, very,
in such
yeah.
little space. So so what I'm trying to do is that I'm trying to use Tong as much as possible, but I'm trying to decode a lot of the things, unpack a lot of the things.